Hello and welcome to this tutorial on 3D analysis. In this tutorial, we're going to talk about and demonstrate some analysis that can be conducted on 3D scenes. So let's get started. So these are the different types of analysis that we're going to be talking about. The first one is isoline analysis, followed by slope and aspect analysis, flood analysis, visibility analysis, viewshed analysis, sunlight analysis, profile and skyline analysis. So let's get started with isoline analysis. Now, an isoline is the most commonly used method to represent a surface on a map. It is a smooth curve formed by connecting adjacent points with the same values. Commonly used isolines include contours, depth contours, isotherms, isobars, and isoheight lines. An isoline analysis shows the distribution of isolines which reflect the change in the values on a surface. A dense isoline distribution indicates a dramatic change in the values of the surface. For example, a dense contour distribution indicates a steep slope. A sparse isoline distribution indicates a mild change in the values on the surface. For example, a sparse contour distribution indicates a gentle slope. Therefore, locations with the same elevations, temperatures, precipitations, etc. can be found through isoline extraction. At the same time, the distribution of isolines also reflects the steep and flat areas of change. Let's demonstrate an isoline analysis. So we have our 3D scene workspace open over here, and we're going to go under DEM, and we're going to right-click on our Chongqing dataset, and we're going to say add to new spherical scene. We're going to add both the image and terrain layers, and we're going to zoom into it right there. So let's choose a part with some altitude. So we're going to zoom into it. Let's say this part here. So we're going to focus on this, and we're going to go under 3D analysis. And all of our analyses are going to be done under this tab here. So we're going to start off with isoline analysis here. Let's click on that. So it gives us a plus pointer and it says, please draw a polygon to proceed isoline analysis, right? So let's zoom out a little so that we can see it from a bird's eye view. So we have this plus pointer here, and we're going to use this to draw a polygon, and when we're done drawing it, we're going to right click to finish it, right? So let's zoom into it, and we can see that we have some isolines drawn there which are visible. So we can change the color of these isolines by using this one here. Let's say we want it to be white, so we can see them white. Let's say we want it to be red instead, so we can see them red. So any sort of visibility is supported. Now you can go ahead and open the help document to see in detail what all of these settings do, and we're going to move on to our next analysis. So the next one in our list is slope and aspect analysis. Now slope is the gradient or steepness of a unit of terrain. The aspect identifies the downslope direction of the maximum rate of change in value from each cell to its neighbors. So both slope and aspect are going to be calculated at each point in the grid by comparing the point's elevation to that of its neighbors. So slope is often measured in degrees or in percent rise from 0 to 90 degrees. Aspect measures the direction of steepest slope for a location on the surface. It is usually measured in degrees, where 0 degrees is due north, 90 is due east, 180 is due south, and 270 degrees is due west. Let's go ahead and check this out. Just like before, we're going to go under 3D analysis, and we're going to say slope and aspect analysis. And same as before, we're going to draw a polygon, and once we're done, we're going to right click, and then we can zoom in to see our slope and aspect analysis going on there. So if we check this flow checkbox right here, this is what happens. The arrows on the slopes, they start moving in order to show you the direction of the slope. So there we have it. We will now move on to flood analysis. So a flood analysis is used to simulate the flooding process over a duration of time with a specified speed and within the maximum minimum elevations. Now this sort of analysis is applicable for terrain and DEM data only. Now this function is used to simulate how the flood level and coverage changes over time in a certain area. It could be helpful for decision makers of disaster management organizations. The analysis results can provide a reference for siting or constructing a project for water conservancy. Now when we are operating this specific analysis in Supermap, we have to make sure that the minimum altitude is set to be at the bottom of the shown area and the maximum altitude is set to be at the top of the island that we can see here. Now we're going to be using the Chongqing DEM dataset as before. And just as before, under the 3D analysis tab, we're going to select flood analysis. We are going to change our location and we're going to zoom into our river here, right there. I'm going to zoom out again to get a bird's eye view. And here, let's say we're going to select this whole area and see how the flooding goes. So we're going to start selecting from here and we're going to draw a polygon like before. And once we're done, we're going to right click to establish it, right? So we're going to stop it here first and we're going to change some things here. So let's say that we want the current altitude here and I'm going to set this up. Let's say we want this at 50 and the maximum one. This basically just changes the duration of the scene. Let's see what it looks like. So it's a bit fast. So we're going to go ahead and we're going to slow it down. Let's say we're going to change the speed to 35 there. So let's play that again. I'm going to see which altitude it starts appearing at. So around 200. So we will set the minimum altitude as, let's say, 175. So let's play that out. So it starts at 175 and it shows a progressive flooding of the area. So let's zoom into that. So we can see slowly the water is flooding its banks and it is going up to an altitudinal area. So let's take a scenario. So let's say the water rises by 30 meters every year. We're going to assume that the seconds here represent years, and if we play it back and we look at the total time, we can safely conclude that this particular area is going to be flooded in almost 84 years. So that's about it for the flood analysis. And we're going to go ahead and move on to visibility analysis. So let's talk about visibility analysis. Often used in 3D analysis, this function is used to determine whether certain locations in a 3D scene are visible to the observer's location. In this analysis, there are observer points and points to be observed. There can be more than one points to be observed. The results of the analysis are lines of visibility that you see here. These are the lines of visibility. Now the visible part is the green part of these lines, and the invisible part is the part in red. So let's go ahead and see it in iDesktop. Now for this analysis and the ones that follow, we're going to be using our CBD data source, and we're going to start off by selecting all of the data sets in this data source and saying right click, add to new spherical scene. And let's say we are going to zoom into waters and we're going to let it load. And we're going to go to a building. Let's say a tall building. Let's say this one here, right? So as we said before, all of the 3D analyses are going to be done under the 3D analysis tab. So we're going to go there and we're going to select visibility analysis. So we have the plus pointer again, and we're going to start off at the top of this building. And let's say we're going to draw a line to the far end here. And we're going to draw the second one to the far end there. And let's say we want one right over here. And another one here, one over here. And let's say one towards this residential area. I'm going to right click to finish drawing our lines. So there we go. This is what this analysis is all about. We choose an observer point, which is this, where all the lines originate from. And we draw some lines towards our target areas. And then we can see whether from this particular observer point, those points will be visible. If we talk about this line here, from this point, a person standing here will be able to see till here where the line is green. But beyond that, the visibility ends and that person will not be able to see. So this is the sole purpose of this particular analysis. So let's move on to our next analysis, which is Viewshed analysis. Now this function is used to identify all the visible and invisible ranges in the analysis area of a scene. So in the previous one we talked about points, and this one we're going to be talking about ranges. So this is what it looks like. We're going to select an area and we're going to be able to see in a range which area is visible and which area is not. Now this is done with models from an observer point at a certain horizontal and vertical edge of view within an extent determined by a specified radius. Now visible ranges are colored in green and invisible ones are colored in red. So let's demonstrate this one as well. We're going to go under Viewshed analysis. So we have our handy dandy plus pointer here again. We're going to choose the same building. We're going to start there and let's say we're going to select this far range. Now in here we don't need to right click. We just need a start point and we need an end point and then we're done. And then we can take a look at this Viewshed analysis. So let's zoom in here. Now from that point up there, this part of the building, of this particular building is going to be visible, while these parts are not going to be visible. Same with all the other objects in this scene right here. So this is the purpose of this analysis and it can have numerous applications. So moving on to our next analysis, which is sunlight analysis. Now this analysis is used to calculate the duration of sunlight in a period of time within an extent defined by longitude and latitude. Now the result of this analysis is a collection of sampling points which have values showing the ratio of sunlight duration to the specified time span. So why is this analysis important? It is important because of the importance of geographical locations, which are used to analyze the change of sunlight spatially. The difference in longitude and latitude and shadow of models result in the difference in the duration of sunlight. So sunlight analysis takes the daily and seasonal change in solar azimuth and the shadow projected by neighboring terrain into consideration and gets the ratio of sunlight duration to the specified time span. So let's see how this is done. Right, so we have our CBD scene here and we're going to go under sunlight analysis. We see our plus pointer again and we're going to select some points here. Let's say we want this area till here maybe. Let's say we'll end it here by right clicking. And we're going to give it some time to conduct its sunlight analysis. So there we have it. The sunlight analysis has been conducted. And according to the sunshine rate, the color of the dots displayed here is going to be different so that you can see what intensity of the sunlight is going to reach specified places. So there we have it. So due to the limited time that we have for these training videos, we would encourage you to go into the help document and read about all the settings that we have here. So let's move on to our next analysis. Okay, so let's talk about profile analysis. Now this shows the change of elevation along the line. So essentially it shows a cross-sectional altitude The research of the profile, terrain, geology, and hydrology features of a certain section, including the landform, outline, absolute and relative elevation, geologic structure, slope features, etc., are very useful for the estimation of the feasibility for constructing railways and roads that intersect through building. It can also provide a foundation for calculating earth volume. So let's see how this is done. Okay, so we have our CBD scene open here again, and we have given ourselves sort of a bird's eye view first so that we have an overall look at the scene. Now we're going to go under 3D analysis and we're going to say profile analysis. We'll get our plus pointer right here, and then let's say we want to zoom in over here and we want to point here and then zoom out again. And maybe we want to go on the right here and we're going to zoom in and select this point. So we have our profile analysis done over here, and as you can see, we can see some cross sections of the buildings, and this can have multiple applications. Now let's talk about skyline analysis as our final step for this tutorial. Now what this function does is that it allows the generation of the boundary between the building tops and the sky from the point of view of an observer, so from a single point. So what it allows us to do is that it allows us to draw a single line skyline of our 3D scene. So let's see how that is done in iDesktop. Right, so this is our scene here, the same CBD set that we have been using. And we have already clicked on Skyline Analysis under 3D Analysis, and we're going to zoom in somewhere where we can see some high-rise buildings so that we can get a skyline outline right then. So let's say we want it from this point of view. So we're going to say first person camera, and we're going to say analysis. So you can probably see a small outline going around each building, and if we turn on the building layer, we'll be able to see it. So there's our skyline that we can use. So that's it for today's tutorial on 3D analysis. Please practice what we have learned in this tutorial so that you understand it better. For more information, please turn to the help document or contact us directly. Thank you.